So last time we looked at that problem dealing with slope. We talked about the slope is important on the position versus time graph. The slope is the velocity. On a velocity versus time graph, the slope is the acceleration. We talked about when a function is continuous and when it's not, and the answer was it's continuous everywhere except where it isn't continuous. And we evaluated the limit. Sometimes it's awesome, you just plug in that number to evaluate the limit. If you're looking at the limit from the right or the limit from the left, though, normally your best option is either a table or typing that in to calculate with the table, I guess. Maybe a graph, I would say. We stopped up over here on number 4, where it was dealing with the limits at infinity. What happens to this function as x gets larger and larger and larger, and what happens to this function as x gets more, I'd say smaller and smaller, but I'd say more and more negative. Okay, so those were the two options. The things that we talked about when you're looking at a polynomial, I didn't make this super explicit at the beginning, but anytime you're looking at a polynomial, that's anything with like 3x squared plus 5x, or 7x to the 9th plus 8x to the 8th plus blah blah blah. Anything that looks like that, those are polynomial. Poly meaning many, nomial meaning terms. The term that's going to dominate, that's going to grow the largest, the fastest, is the term with the highest exponent. So whenever we are comparing polynomials, and I say which one's more powerful, which one's going to grow faster, essentially we're just looking and saying which one, this guy or this guy, has the highest power exponent. Okay, has the highest number there of the exponent. 3x to the 5th plus 2 versus 7x to the 9th plus 8x plus, who cares, normally it would go down. We've got x squared here, x to the 9th, this guy's going to win. It doesn't matter about the coefficient. What matters is that power of x. So that's the first thing. Then we also noted that if the numerator grows faster than the denominator, then if the numerator wins, then your ratio is going to approach infinity. If the denominator wins, the denominator is growing faster. It's like it swallows it up and it approaches 0. And if they're a tie, if you've got an x squared as the highest term and an x squared as the highest term in the denominator, then you look at the ratio of the coefficients. So if it was 3x squared plus 5x divided by, 7x squared minus 9, and we want to know the limit as x approaches infinity of this ratio right here. Well, like I said, the big powerful term here is the 3x squared. You just almost cancel that, cross that out, just ignore it. Down here in the denominator, it's the 7x squared. Tie goes to, not the runner, tie goes to the coefficients. Just a baseball reference there for you. So tie goes to the leading coefficients. That's 3 over 7 in that case. Simply like a 3 over 7. Little fun fact, that is what we would call the horizontal asymptote. Okay? Because what we're saying is, whatever's going on around here, I don't know, maybe something kind of like that, I don't know. As x approaches infinity, as this function grows farther and farther this way, the y value is approaching 3/7. So 3/7, we're getting closer and closer to that. So if you have this tie goes to the runner or tie goes to the coefficients situation, then that number right there is the horizontal asymptote. Okay? If we have a situation where the limit of your function goes towards infinity, so if you've got like the limit as x approaches infinity of x squared, 2x squared plus 1 over x, this has an x squared, this has an x denominator. The x squared term is going to win, and so we said that means the numerator wins and goes to infinity. That just means that you've got something where your function is increasing without bound. It would look something like that. If you had the other situation, very similar to what this one is right here, the limit of 3x plus 1 over 4x to the 5th plus 2 as x approaches infinity. As x gets larger and larger, we saw that this denominator is going to get bigger much faster, and we said that that approaches 0. Okay, that means that my function is going to be getting closer and closer to 0, so it's going to look something kind of like this. It might not go up there, it may have gone down, whatever, but the point is that as x gets larger and larger, the function is approaching 0. So I guess you could say that's also a horizontal asymptote situation, because you have an asymptote that looks like that. Whether or not it's above or below, you've got a graphing calculator, you can figure that out. Okay. The last thing that we need to deal with are situations where maybe there's negatives in front of these guys, and I should say, when you've got like a negative in front of this, so you're doing like as x approaches negative infinity. Okay? And it's not a bad deal as long as you remember just a couple things. So if you've got like the limit as x approaches, we'll just do a regular situation where you've got infinity up there. 3x squared plus who cares, and then let's just say 5x plus who cares. Those are the biggest terms. Under normal situations, Alex, we saw that this is the numerator is going to win, so it's going to approach infinity. But what if I stuck a negative out front there?
Negative?
Then this will approach negative infinity. Yep. Okay. So that's not that big of a deal. What if I've got a lot of stuff I'm trying to get through here, so I'm not going to write all the different limits and stuff like that, but you just assume it's all the same. What if I had a negative down there? Well, it's the same kind of situation. This is going to be something really large, okay? This is going to be something large, but not as large as this one, but this one's negative. So essentially you have a positive divided by a negative. So it's going to give you a negative infinity. Okay? So what you first do is you first kind of ignore all the minuses and stuff like that and just look and see who's going to win, numerator or denominator. Okay? And that's going to tell you whether you're approaching infinity or 0 or some number. Then you start looking at, is there like a minus sign here or here? And if there's a minus sign like right there, then okay, you've got a positive term over a negative term. You're going to have negative right there. So now you're ready to deal with the situation. What happens as x approaches negative infinity? We'll deal with these same two situations. First, I'll go with the positive, x squared plus negative. Once again, just ignore that minus right there, because we're just looking at x is negative 1 million, negative 10 million, negative 100 million, so on and so forth. X is getting very, very large, okay? So that situation, we've got x squared is going to get really large, x squared, large but not that fast, okay? So this is still going to win. We're definitely looking at some sort of infinity answer right there, okay? And so now let's think about what happens. I'm plugging in negative numbers here, okay? And I'm plugging negative numbers into this x squared term. Well, a negative times a negative is a positive, okay? So I'm looking at a positive here. In the denominator, I'm plugging in straight negative numbers, okay? So this is always going to be negative in the denominator. And so a positive number divided by a negative number is negative. And so that's going to be negative infinity. That's how you evaluate that. Okay? And just go ahead and think through your rules. You know, if it was as x approaches negative infinity and it was 3x cubed plus a whole lot of stuff over 5x. Okay. Once again, you're like, okay, x cubed over x cubed wins. So I know I've got some sort of infinity answer here. Then we play this back and forth guessing game here. So I've got the numbers I'm plugging in are negative. So that means this is going to be a negative times a negative times a negative. It's going to be negative up there. You're like, aha, I know where this is going. With the denominator, though, I'm plugging in negative numbers. So that's going to be negative numbers. And so we've got a negative over negative, and so now you're looking at a positive. So you just gotta kind of have to kind of go through that process. Think about the type of numbers that you're plugging in, and remember that if it's squared, negative times a negative is positive. If it's to the fourth, negative, 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 that's also going to be positive. To the sixth, any of those even numbers, negative numbers, they're all going to cancel each other out. But if it's the odd powered exponents, then you end up with a negative number. They don't cancel out. I guess just for the sake of completeness, I'll show you what happens as x approaches negative infinity when we have those other situations, such as the limit as x approaches negative infinity of 5x plus blah 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 over 3x squared. So this is a situation where the denominator wins. Denominator is going to grow bigger faster. Well, what happens when the denominator grows bigger faster? Approach 0. Done. Don't need to worry about positive 0 or negative 0.
That's it.
That's it. I mean, there's no. Now, you could figure out whether or not so we know that whatever happens, it's approaching 0. Okay, as x gets closer and closer to negative infinity. The only question sometimes is, does it approach 0 from the negative, from the below the x-axis, or does it approach 0 like that? Okay? And there are algebraic tools that you can do to figure it out, but I say, why bother? You got a calculator. You know what I'm saying? So just graph it. I mean, I don't even know if they're ever going to ask something like that. So if you've got the 0 situation, then no big deal. The only one that might be a little tricky, I guess, is when you have that tie situation, where you've got 7x squared plus blah 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 over 8x squared plus blah 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 blah. You can see that it's a tie, so we know that it's going to be definitely 7 over 8. We might want to then ask ourselves, is it going to be positive or negative? Okay, and well, we've got negative infinity here, so that's plugging in negative infinity times negative infinity. So that's going to be positive. Okay, and over here, that x looks ugly. Negative times negative, still positive. Yeah. Okay, so you're looking at 7/8. So that really didn't make any difference. Just to be clear, if it happened to be the cubed, as x approaches negative infinity, negative infinity times negative infinity times negative infinity, still negative. Negative infinity times negative infinity times negative infinity, negative. So they still cancel out, and you still end up with 7/8.
Okay. So
this, as x approaches negative infinity, I'm not really worried about it when it goes to 0 or when it goes to a specific number that's horizontal asymptote. The only thing that's going to be kind of wonky is when I've got that infinity situation, and I've got to kind of figure out is it approaching negative infinity or positive infinity. Okay? All that said, let us now apply those principles to this particular problem. We already found out that the limit as x approaches positive infinity was 0. Function there. I'll take that. Sorry. And so now the limit as x approaches negative infinity, I'll write the whole thing out here. 3x plus 1 over 4x to the 5th plus 2. So it's infinity. So that let's just deal with numerator, denominator. Who's going to win? Denominator. So swallows it all up. Goes to 0. Okay. So the options here. I think you have to choose like A and B together. I'm not sure. This is kind of an interesting setup for me. So remember, if it approaches 0, that essentially means is we've got a horizontal asymptote at 0. That's what that means. We're getting closer and closer to 0. So this says option B, the limit does not exist. No. The limit does not exist. No. Identify the horizontal asymptotes. The function has one asymptote, or the function has two asymptotes. The top asymptote is this, and the bottom asymptote, or the function has no horizontal asymptotes. I would say, based on this, the function has one horizontal asymptote, and it's y equals 0. Because we saw as x approaches infinity, we're going to 0. As x approaches negative infinity, we're going to 0. So I kind of like that answer. Oh, I see. Okay, I take all that back. I understand what they're doing here now. This says the limit of f as x approaches positive infinity, we put 0.
Negative.
And then as x approaches negative infinity, I just wasn't paying attention to the problem, equals 0. Okay. And then this one, the function has one horizontal asymptote. Okay. Y equals 0. Let me make sure I'm leading you down the right path. And I am. Those are the exact right answers. Anybody have a question about all this funness? All right. All right. Probably pick up the pace a little bit here. This is a function and an interval of its independent variable are given. The endpoints of the interval are associated with the points P and Q on the graph of the function. Answer parts A and B. Okay, so we're going to give us a function and endpoints. Got it. The volume of a gas in cubic centimeters is given by V equals 9 over P, where P is the pressure in atmospheres, and P is between 0.5 and 4. So when they say up here, the interval are the associated points P and Q, they're saying that this right here is P at 0.5 and 4 is Q. Those are the endpoints. Okay. Sketch a graph of the function and the secant line through P and Q. Okay. Well, that's going to be real quick. You guys have a calculator? Let's go ahead and graph this sucker. It says V equals 9 over P, so that's just going to be Y equals 9 over X. And that'll tell us real quick whether or not my graph is going to look like A and B or like C and D.
It looks like A and B.
I agree. Then they want us to find these, so they've got a point up there and there, or they've got a point here and here. We're looking at something that's at 0.5 and something that's at 4.
It would be.
It's B?
Yeah.
Because, oh, well here it looks like they're stopping at 3,
Yeah.
right? Okay, there we go. That's nice and easy. It's going to be helpful for us to know those exact values, though. Looking ahead where I know that it says what's the slope of the secant line. I'll read the part. Find the slope of the secant line in part A and interpret your answer in terms of the average rate of change over the interval. Include units. Okay, so let's just make a little table here. It will say little p and volume. That's the x and the y. We're interested in 2 points, the 0.5 x value and the 4 x value. Table can help you out with that. Or 9 divided by 0.5. What's the table say?
2.25. Are we looking for?
Oh, okay, so I'm right on the 0.5?
Yeah, you're right.
Okay. And this one is 2.25?
Yes, sir.
Okay. So those are the points there. And they say find the slope of the secant line. Well, let's go back to algebra 1, maybe even earlier. So the slope, remember the slope formula? Minus y1. Yep. If you don't have that memorized, get it memorized. Okay?
So those would be our x and y?
Yeah. So I wrote little p because that's little p, that's the independent variable, and then v is your dependent variable, okay? And it's actually helpful when we do our slope formula to write the units down, because then it'll make our life easier when we have to answer the tough part of the question. So, what do they give us as the unit, the x units? They tell us. So look up here, the volume of the gas, V, in cubic centimeters, okay. So V is going to be measured in cubic centimeters, so I write that, centimeters cubed, okay. And is given by V equals 9 over P, where P is the pressure in atmospheres. Atmospheres is a way of measuring pressure. 1 atmosphere is how much pressure you're feeling right now. If you ever dive underwater, you can feel more and more pressure, your ears start to feel the pressure, stuff like that. Anyway, so the unit here is ATM, atmospheres. So when I calculate the slope, that's going to be y2, so I'll say, so it's 2.25 cubic centimeters minus 18 cubic centimeters over 4 atmospheres minus 0.5 atmospheres. I await the final number.
So 2.25 minus 18 is negative 15.75.
Okay. Keep that running in your calculator. Now do 4 minus 0.5, 3.5, and do the division.
Negative 4.5.
And the units?
Cubic centimeters over
18.
Yep. All right. So, this is negative 4.5 cubic centimeters per atmosphere. So we can actually tell there that the volume is dropping, right? You can tell it by the graph, and we would say that it's up here. It was at the whatever number. Is it 18, and now it's at 2.25. Okay. Forget this atmosphere stuff. Let's just think temperature. Okay. Just so you can kind of get a feel for it. Okay. It was 18 degrees. Now it's 2.25 degrees. Okay. It's dropping. Okay. Sort of like maybe you could say, you know, every hour, if you want to think of it like that. Okay. So it's dropping. But instead of temperature and, you know, time, we have pressure and atmospheres. So it's helpful sometimes when you have something like a rate of change like this is to write over 1, because what this means is that in words we would say the volume is decreasing or dropping at a rate of 4.5 cubic centimeters per 1 atmosphere. So every time you increase the atmosphere by 1, so then that would mean more pressure, then the volume goes down. Which, if you think about it, that kind of makes sense. If there's more pressure, you've got some air or whatever, you're putting more pressure on it, then that is going to take up less volume. It's going to be condensed, you know, or compressed. Okay? So the volume is getting smaller every time you increase the pressure of the atmosphere. That's probably a little more context than you need, but let's go and look at answer the question. The slope of the secant line is negative 4.5. This means that the blank changes at an average rate of blank blank, or over the interval of, okay, so this first one means what it means, the slope is the mathematical thing that we're using to calculate.
The volume?
We're looking for volume. What is it referring to in the situation? So we're saying the volume changes at an average rate of Well,
-4.5.
negative 4.5, and then we would say cubic centimeters per atmosphere. That's this option, that option, over that interval. It's a great problem because it deals with like an actual thing, but it's not so much great because sometimes your mind is focusing on the volume and the pressure, not so much on the mechanics of what we're doing, okay? But that's okay, you can handle two things at once. The thing that we're doing is we're finding the slope. The way that we find the units for the slope is by literally writing those units into the slope formula, okay? And then from there, we know that these are volume units and these are pressure units. So that's how I was able to say the volume is changing at this rate as the pressure is changing. Okay, so what we're looking at is this is a rate of change. How much is it changing? Okay, anybody have any questions about these type of problems? There might be another one in here, never know. Let's keep going. Difference quotient. I think this is kind of what he was working on yesterday, right? Was he taking the limit of the difference quotient or just doing difference quotient?
Yesterday you were saying.
Okay, we'll get there. Right now we just gotta do good old difference quotient. This is simplify the difference quotient f of x plus h minus f of x over h and f of x minus f of a over x minus a by rationalizing the numerator. Great. This is literally we're just going to plug this function here into this expression and see what we get. Okay? So remember all of our algebra skills here. So this is f of x equal to negative 7 over square root of 3x. We're going to plug that first into this guy right here, f of x plus h minus f of x. So, just as a little side note, if I've got f of x is equal to negative 7 over square root of 3 of x, this little side note just kind of help you remember something. F of x plus h, Kevin knows this. He's playing on his phone. Kevin, you remember when I've got f of something on the inside right there? What does that mean? What do I do with that x plus h?
You plug it in.
You plug it in where?
Where there's the function.
You're closer.
I know what it is. I don't know how to say it.
Plug it in for where you see the x, right? So I would have negative 7 over. Cause I remember I asked you like that a million times last year. I don't remember that, but I remember that. Negative 7 over square root of 3 times, but then instead of saying x, I'm going to say parentheses x plus h. Does that make sense? That's just make sure we're very clear on what that means. Okay? Because we're going to utilize that fact up here. So keeping that in mind, look at this expression. It's f of x plus h, which is this whole guy, minus f of x, which is this guy, all of that over h. This is going to be a big problem. Because we're going to have like a fraction with fractions, and then we got to combine everything. Let's get going. So f of x plus h, just writing what they want down here, minus f of x all over h. I'm going to figure out what this guy is first. So that we saw that was negative 7 over square root of 3 times x plus h. Just copying straight down. Copy down the minus. Copy down the f of x. Negative 7 over square root 3x. Copy down the divided by bar. Copy down the h. Okay? And all they want me to do now is simplify until I get something really nice where they say rationalizing the numerator. Okay? We don't like the fact that there's these guys.
So multiply by the conjugate? Or not yet?
Possibly. Yeah, you could. The problem is at that point, if you multiply by the conjugate, we're still going to have square roots there. I'll tell you what I don't like about multiplying by the conjugate right now is that I've already got fractions and fractions and stuff like that. I at least want to try to get rid of this main fraction right here. So what I'm going to do first off is I'm just going to say, I'm going to keep the numerator as is, and then I'm going to multiply by the reciprocal of the denominator. If you remember good old division, you know, if you had 1/2, this you saw in grades, junior high, 1/2 divided by 3/4, you did 1/2 times 4/3. Okay, well, it's up at a notch here. 1/2 divided by 3/4 would be the same thing as 1/2 times 4/3. It's the same kind of thing, right? So that's what I'm going to do here, recognizing that this is a numerator and h/1 is in the denominator. So I've got -7 over square root 3x plus h. Let me clean this up a little bit. Minus a minus, so that's plus 7 over the square root of 3x times h over 1. And then I can just distribute that h there. So I've got -7h over the square root of 3 times x plus h plus 7h over square root of 3x. Now, they say rationalize the numerator. I would say, oh, well, I did. There's no rational things in the numerator there. But looking at what their answer is, what they also want you to do is they also want you to combine this into one big thing. Emily, another thought, multiply by the conjugate, that is something we are going to have to do at some point.
Yeah. What verse you want to?
But if I would do that, then I'd end up multiplying by the conjugate. It would be like -7 plus some square root plus square root, and I'd have to have that same thing in the denominator. You see what I mean?
Yes.
It'd end up being kind of messy. All right. At this point, I do want to combine everything, so that means trying to find a common denominator. Okay? So this is kind of like a situation where back in Algebra 2, you had like 2 over 5x plus 3 over 7x. And you needed to combine those. And the way you combine those was you had to find a common denominator. And you kind of looked at this guy, and you thought through all the multiples, and you looked at this guy through all the multiples, and then you said, you know, whatever, who cares? I'm just going to do it the easy way. I'm going to take this term over here and multiply it by 7x over 7x. And I'm going to take this guy and multiply it by 5x over 5x, just because then I know I'm going to get the same denominator because everybody's got the same thing.
Also, you could multiply by the square root of 3h times square root of 3h.
I could, and that would will get rid of the square root of the denominator here. However, I still have 2 terms. Yeah. Okay, so I'm going to write this. So -7h, I don't mind using a board space because I can erase. So -7 over square root 3 times x plus h times this other guy's denominator, square root of 3x over square root of 3x plus 7h over square root of 3x times that other guy's denominator over itself, square root 3x plus h over square root 3x plus h.
I'm the left-handed teacher and the right-handed teacher.
make a difference?
Yes, I love that you're left-handed, actually.
Sort of a natural selection, I guess. I'm just kidding. No, that sounds kind of bad. Anyway, just natural advantage is what I was going for. So here we go. Multiplying the numerators there. We've got negative 7h times the square root 3x all over our favorite common denominator. Square root of 3 times x plus h times the square root of 3x plus 7h times the square root 3x plus h all over common denominator square root 3x plus h times square root of 3x. Okay, so I've got a common denominator. That's great. Let's go ahead and combine this numerator. I have negative 7h square root of 3x plus 7h
So then the,
square root of 3x plus h all over everyone's favorite denominator. Square root 3x plus h times the square root of 3x. Hooray, I got it all as one term.
this is so
I'm beginning to wonder if this is ever going to end. And I'm beginning to wonder, this does not look much simpler than what I started with. But, I said, what the heck did they say? Rationalizing the numerator? Well, I'm still going to have to combine those suckers. I'm still going to, I'm looking for shortcuts. I'm not seeing any at this point.
Is that the right answer then?
We're not, because we still have not rationalized the numerator. We've just got everything as one nice numerator. Okay? So, what I think I need to do is, at this point, to get rid of those square roots, is to multiply by the conjugate. That's the way that you get rid of stuff. So I'm going to multiply this by negative 7h square root of 3x minus, yep, 7h square root of 3x plus h all over negative 7h square root 3x minus 7h square root 3x plus h. About this time you're thinking, I need to skip this problem and come back to this one on the test because it's going to take a little bit longer, okay? But this is helpful here for us. We have sort of an a plus b, a minus b situation in that numerator. That's the whole reason why we did it. And so, we all know that a plus b times a minus b is going to be a squared minus b squared. Remember from your algebra, I'm not going to revisit that at this point because we're running out of time here. So, that's this term squared, so this term times itself. So, that's going to be negative 7 times negative 7 is a 49. H times h is an h squared. Square root of 3x times square root of 3x is just 3x. Minus this term's squared, so 7 times 7 is a 49. H squared. Square root of 3 times x plus h is, or times square root of 3 times x plus h is 3 times x plus h. All over this times this. Square root 3 x plus h times square root 3x times the quantity negative 7h square root 3x minus 7h square root 3 x plus h. Almost done. We just need to look and see if we can pull anything out of the numerator and the denominator. Turns out we can pull out quite a lot. I might be able to pull out a 49 and a 3 from each one of that numerator. So pull out a 49 times a 3. And I'm left with, I can also pull out an h squared. Gives me 3x minus everything out here. X plus h. Hold on, I've yanked out that 3. The denominator, I've got a negative 7h and a negative 7h I can pull out of that. So, negative 7h. This term still stands. Square root of 3, x plus h. Square root of 3x. Parentheses. Pull out a negative 7h, so all I've got left here is square root of 3x. Pull out negative 7h, so I've got plus square root 3 x plus h. Oh my gosh, are you serious?
I'm sorry.
X minus x.
He's like, what's the problem?
Yep, well, we'll look and see if there's a faster way. No promises. 49 divided by negative 7. Negative 7 times 3. H squared over h. Got an h. X minus the x cancels out. So I just have another h up there. Actually, it's a negative h. Because that negative distributes here. So that negative 7 canceled out 49. That h cancels out that h. And then this whole denominator as is. Square root of 3 x plus h. Square root of 3x times square root of 3x plus square root of 3 x plus h. That negative would turn positive. The h would be squared. Then we'd have 21. Let's check our final answer. Very similar, but they have it simplified further. Like I said, this is the one that you would, at this point, you're like, I'll skip this one, come back later. Okay, we're right so far. On Monday, we'll look and see if there's any faster ways of doing that one.